Greetings folks and welcome to the Electromaker podcast. This is your roundup of all things maker and embedded and lovely. And on this week's show we are taking a look at the nRF54L series of microcontrollers from Nordic Semiconductor. Although as always I do get slightly distracted and talk not only about that but the SDK, how you can use it with VSCode and the legacy of the nRF54 when it comes to the comparison to the nRF52. Because while the nRF54 is, you'd think, the follow-up to the nRF53, and it will be in the nRF54H series, the nRF54L series is designed to do everything that the nRF52 did, but with more power for processing, but surprisingly using less battery power. We also take a look at some of the things that have been happening behind the scenes here at Electromaker, including new shows on the YouTube channel and our product of the week, which is a Halo Wi-Fi gateway that you can win one of, which can give you Wi-Fi up to 1 kilometer away, which is wild to me. And we also take a look at the latest from the Open Book project. The Open Book Touch is a fully open source e-reader with an ESP32 running the show. It has a touchscreen, it has a backlight, it is a very exciting thing indeed. So, with all of that to get on with, we should probably get on with the show. But just before I do, a quick reminder that while we do occasionally get sponsorships in the show, we do not run any sponsorships on our podcast from third parties, and we don't have any YouTube ads or anything. But we do have an online store at www.electromaker.io, and it would help us out a lot if you took a look there when you're thinking of getting your next thing for work, for play, or as a gift. Anyway, let's get on with this week's podcast. We're going to start this week's show by taking a look at the nRF54 series from Nordic Semiconductor. Now, if you are familiar with Nordic parts, you probably know the nRF52840. It made its way into so many different things, and whether you have one of the official Nordic development kits or a board featuring it, because there are Arduino boards out there with it on, some of the Seed Xiao tiny little boards have it on. A personal favorite of mine is the Seed Xiao nRF52840 Sense, which has some sensing components on it as well. Well, the nRF54 series is the spiritual successor to the nRF52, and it actually supersedes it in a variety of surprising ways. So Nordic Semiconductor has a reputation for low power, as in low power draw devices with wide functionality working in Bluetooth, and also more recently working in Wi-Fi and working in cellular. As it just so happens, I have an nRF9160 development kit on my desk in front of me. It's what I've been working with most recently. But Bluetooth Low Energy is probably what they are best known for, and the nRF52840 is a chip that has become ubiquitous. The nRF52 series has found its way into almost every corner of consumer and the industry, consumer devices and industry devices, and it is almost certain that you own a device with one of these chips in it. So the fact that the nRF54 is supposed to be somewhat of a successor to this is actually quite a large set of shoes to fill. But as it mentions here, it takes the nRF52 series to the next level and is designed for the next generation of Bluetooth Low Energy products. So what possibly could they have changed? Well, if I put myself here, because we don't need to look at the nRF54H today, on the side here we have the nRF52 series, and depending on which variation you have of it, it will have a 64 MHz ARM Cortex chip on it and varying amounts of RAM and different configuration options depending on what you need. The nRF54 series has a 128 MHz ARM Cortex M33 and a 128 MHz RISC-V coprocessor, and if you spend the time to come and have a look through this list, which I will be linking in the description, you will see that it is an upgrade on the nRF52 series in almost every way, adding several things that weren't there before and improving on things that were. Now, before we go any further, I think a really good way of showing the difference between these two generations of chips is with an example. And we were lucky enough in November last year to actually meet with Nordic at the Electronica conference and have an interview specifically about this. So once again, I will link this in the description. There's a blog post here, and there is a video that we actually shot at the Nordic booth with a device that shows both an nRF52 and an nRF54 side by side doing the same tasks. And here's the thing, as you would expect, the nRF54 does that task faster, but it wakes up faster, goes to to sleep faster and uses less power overall to do that. So when they say they're trying to make a spiritual successor to the nRF52, they're very serious. They're not just making a faster chip, they have actually brought down the power draw required to use the chip as well, which was one of the big reasons the nRF52 series was so loved. It is an incredibly low power draw chip for a huge amount of functionality. So the nRF54L15 is just one of several system-on-chips that Nordic provides that give you different variations depending on what you need. Maybe you need ultra low supply voltage. Well, there's one of those here for that. Maybe you need something that's pared down a little. There are variants that go down to the L10 and L05 as well. And of course, each one of these has its own product page where you can find the datasheet and the full lineup of everything that it can do. But if you, like me, are still learning how to do all of this kind of stuff, I cannot recommend the development kits that Nordic make enough. This is the nRF54L15 development kit, and as you can see, it's actually laid out a little bit different to some of the older Nordic development kits, but it is used in exactly the same way. The nRF Connect SDK is built upon Zephyr, and I know Zephyr is called the Zephyr RTOS, but really it's more of a framework. You can learn a lot about Zephyr and how to use it without even touching the actual real-time side of it. It's more of a configuration tool than anything, and the nRF Connect SDK on top of it doesn't just add custom bindings for Nordic things like security or things that go on with the board. They have created a completely custom VS Code plugin that allows you to use the nRF SDK on top of Zephyr to program your boards, to modify your device trees and your configuration files. They even have a visual device tree, which is a wonderful thing that allows you to see everything that is turned on and off in your board and look at what everything is doing, which was a great help to me when I was trying to learn about things like device trees in Zephyr. Now, if you would like to find out more about the nRF54, of course, heading to any of the links I've already shown you would be a great idea, but Nordic has taken it one step further and they've created a custom course just taking you through the fundamentals of the nRF54L series, which is incredible. I've used these Nordic courses before in order to just learn about the SDK, but this is less of a hands-on do-it-yourself course and more just a structured walkthrough of everything you need to know about the device, and in terms of how you can use the event system, the GPIO, the peripherals and the system components, and at the end there is even a demo which shows the low power consumption demo and how you can set it up with your computer with a power profiling kit from Nordic in order to actually show how little power certain elements of this device are using. And if you see this and think, how do I set something like that up? Nordic have you covered there as well. I just want to point out one small aspect of the Nordic Connect and SDK fundamentals, which is still, in my opinion, probably the easiest entry point into both Nordic products and the Zephyr project as a whole, because I understand there is somewhat of a learning curve there. This takes it step by step and teaches you everything you need to know to get things up and running with real examples, and you do things like reading buttons, controlling LEDs, all the basic stuff at first, through to printing messages to the console. I wanted to mention specifically this one here, the I2C example. The power of the nRF Connect SDK and Zephyr is that once you have working code, you do not need to rewrite that code ever. You can write whatever code you want, and all you need to do is change the configuration file in order to actually change the board that you are using. So, for example, let's say that I had this little nRF9160 board here, and I wanted to do this BME 280 temperature sensor example. This is showing how to attach an I2C or SPI sensor to your board, and in fact I have a DAC. I thought I actually had that sensor attached. I could have done it on screen here, but this is the overlay that you create when you create your code. The first time you see it, it seems quite dense, but you get used to all of these things. You learn them in the same way you have learned how to write application code or how to flash certain devices or read data sheets. It's just a thing that you slowly start to take in over time. Take it from someone who is not a trained engineer and very much just an enthusiast, that this stuff starts to make sense after a while and then becomes incredibly useful, because you can write your application code, you can do whatever you want with it. And my nRF9160 is great, but I've just got the nRF54L15DK, and all I need to do is change a couple of things in the configuration file, all of which is documented in the board device tree of the nRF54. And now, between this And that's the only changes you need to make in order to completely move the application processor and development board that you are using over without changing a single line of code. This is why people get so excited about Zephyr. This is why Nordic has built the nRF Connect SDK on top of it. And again, I want to very quickly, before we stop here, show you the nRF Connect VSCode plugin, because it really is something quite special. Now, this section is specifically about the nRF54L15, but I did want to spend a moment talking about the VSCode plugin for the SDK, because the nRF Connect SDK is built on the Zephyr project, as we've talked about many times, which has a steep learning curve. There's no way around it. And this is a situation that many of you have probably found yourself in. I've opened an example project, but this time directly from the nRF SDK here. All I've done is installed the plugin and opened an existing application. This is, again, for the BME temperature sensor, the same one that is in the nRF Connect Fundamentals series we talked about a moment ago. And I've created a build configuration for my board. In this particular instance, it's the nRF9160 DK, but it could be the nRF54 sitting in front of me just as well. The entire point is that you can build for every single board and not change a line of code. Now, what the code is doing here does not matter all that much. The only thing that you really need to understand is that this code is reaching out for the sensor and doing something with it. It doesn't mention the board in the code at all. And that's the reason that this has failed. If we look in the source file here, you will see a bunch of different overlay files for different boards. This Adafruit Feather ESP32S2 is a good example. You can see that here they're specifically saying that the I2C configuration requires this BME and that is what's going to actually connect it to the correct board. So how do you actually deal with a problem like this? Well, one of the nice things about the Connect SDK, as I mentioned, is being able to visualize the device tree. And even if your build fails, if you click on your current build context and then click on the device tree overlay file, you get this visual representation of everything that is going on inside the chip and what's going on the board. You also get a list of the different things that are in the context. So if I look here, it shows all the GPIO, it shows the flash, but what we're specifically interested in here are the buses, the I2C bus. So I2C0 is what the Adafruit Feather board used, but we're not seeing any nodes there. But on I2C2, we are. So if we open this up, we can see here, these are the pins that the SDA and SCL pins of the sensor will be attached to. And we can look here and we can actually see, okay, so firstly, this is I2C2, not I2C1, but this particular development board has an Arduino header on it, and the two pins that we're connecting to, and in fact, the two pins that this little I2C DAC are connected to, are those two I2C pins. So we may as well use the ones that are already activated, and we can see here, this is Arduino I2C. So how can we actually use this in our code? Let's assume that we need our own overlay for the board that we are using, since all the other boards have done that. And in fact, in this particular example, it even mentions there is an I2C overlay specifically for example that you can take, which is exactly what I did. I found this particular device tree activator. I've made this little overlay file, and if I now rename it so that it has the correct name, you will see that we are saying on the Arduino I2C line, as it were, the configuration option, we want to add this particular sensor. We're saying status OK in order to say, OK, bring it up and make it work. And now if I go back to my build, and as you can see, we now have a successful build. And this is where the real power of this system comes in, because now I do not need to change my source code at all if I decide to switch this over to an nRF54 board, for example. I can just literally make a new overlay file and then make sure that we poke the right parts of the board, as I just showed you before how to do using the device tree editor. You can see exactly what buses are active and exactly how they're working. And then you can just swap out hardware or even swap out the sensor just by changing these details. And that's where the power of the Zephyr project comes in, and the nRF Connect SDK on top of it. And this particular VSCode plugin gives you a visual representation and so many little ways of helping to actually get started with doing all this kind of stuff. So please excuse that slight tangent. This is a section about the nRF54L15 after all, but I thought it was important to talk about the underlying systems of the nRF Connect SDK and Zephyr beneath it that you use to actually develop using this part. Because everything that I've just showed you applies to everything on the chip all of its peripherals. If you do design your own board with the chip on, you can use the same application code you used on the development board and just change the configuration files to your custom design. If you want to add one of the nRF54L series to add Wi-Fi locationing to your device, you can put that on the board and just determine in the config files in the nRF Connect SDK how they talk to each other. Your application code from your development can stay exactly the same. It is incredibly powerful, and if you would like to find out more about the nRF54L15, how you can get a hold of them, get a hold of the DK and maybe start using it, head to the link under this video. Next up, we're going to be looking at Duke Nukem 3D running on a microcontroller. Now, this is from NextHack, a name that you have come across on this channel before, because NextHack is the one who has ported Doom and Quake and now Duke Nukem 3D to a variety of Silicon Labs parts. This time round, he's chosen the Arduino Nano Matter as his target, and as always, the results are incredible. So the original source for this is in the embedded subreddit, and here you can see it in action. And of course, I will link this down below. It's using the MGM240S, which is a wireless system on module. But this is the chip that is on the Arduino Nano Matter board. It is a Matter-capable chip, unsurprisingly given the name. But yes, NextHack seems to have a penchant for taking classic games and making them work on quite constrained machinery. Because while the Arduino Nano Matter board is incredibly capable of a lot of stuff, this is probably a stretch. But as it says, it's running on it. It's using a external flash IC to actually store the file for the game, the GRP file. And you can have multiplayer, as you see here, up to 4 players actually holding these handheld boards and playing with each other's. Both the original and the Atomic Edition episodes are supported if you're playing single player. And it has, state exact save games and various other things as well. Now, there's a history here with this. We've actually talked about it before several times. I talked about it on the Electromaker Show a little while ago. There's me looking really rather beardy in the attic. This was the original Sparkfun Thing Plus Matter version, which had multiplayer Doom on it. We actually had a little play of this port at, I think it was Embedded World. There's some video of the Embedded World walk around where you can see Rich looking over my shoulder and filming me playing it. I'll put a link to that in the description if I remember to. And this was one thing. And then came Quake, and this one really hit for me because Quake is pretty much the game that defined me in terms of childhood, getting into games and computing and all that kind of stuff. Quake was a big one. And getting it running properly, once again, on this time a Sparkfun Thing Plus MGM240P, but you may notice the MGM240 series, once again, the same microcontroller, or the same series of microcontrollers, getting Quake working. And yes, now we have Duke Nukem 3D. As you saw from the little video here, it is working surprisingly well and with a surprisingly high frame rate. Of course, if you're watching this show, you're probably interested in the real nitty-gritty, the technical side of how this was done. And there is, well, a GitHub, of course, which you can find. I will link to it. Although I'll probably just link to here because this Reddit post has a link to the repository. It also has the hardware design files, a quick article on the Scilab's website, and a long, more technical article on NextHack's own website. The GitHub is here if you would like to try and do this yourself. And a really nice long read that I haven't even got all the way through. I found about this one just before I started filming the show, so I've only had a short amount of time to read about it, which is also why I'm speaking so quickly and enthusiastically about it, because that tends to happen when I'm just cannot wait to talk about a thing. But this is the full write-up of how it was done. And I really love this. Clearly, the Arduino Nano Matter was not designed with playing Duke Nukem 3D in mind, but it's just a real testament to seeing something and seeing the constraints of it and working within those constraints in order to make it work. And I'm sure I said something very similar the last time I spoke about this, and it's just something that I really appreciate. It's the same spirit I find for people who are working with the new CH32V003 chips and seeing what they can get out of those. And yeah, this is just a wonderful project. So if you would like to find out more about it, I will link the Reddit post in the description below. I'll also link the last 2 examples of it, of us talking about it on the show, in case you would like to see that as well. So as I mentioned at the start of the episode, if you would like to support us, the Electromaker shop is the best place to do it. If you head to electromaker.io, you will hit our shop front. But just a quick reminder, we do have a large project hub, which is full of our community members who are making wonderful projects and sharing them with us. I'm hoping to be able to talk more about these on the show again quite soon. We've just been somewhat time constrained, and one of the reasons we've been time constrained is that Electromaker has been expanding the kind of things that they are doing in-house. You may have noticed a new series called Behind the Tech that has showed up on our YouTube channel, where we're going deep on various different subjects in terms of what you can use for development if you want to make, say, IoT products. And in fact, the last two videos cover exactly that. This blog is for the cellular IoT tools you might want to use in 2025, 2026. This is specifically talking about different development kits. This is a video from Robin talking about that. And if you are looking for something which is more a kit that you can use right from day one right through to production, there is another Behind the Tech episode featuring me that talks about, again, IoT development, but this time taking something that you, from day one, start with exactly the kind of hardware that you're going to be putting out, with all of the considerations, including things like certification, which is a real can of worms. And if you would like to know a little bit more about either of those, you can, of course, head to the blog or just head to our YouTube channel and find both of those. Our Product of the Week series is also still going strong as well, and our most recent one is the Morse Micro Halo Link 1. This is a long-range Wi-Fi gateway using the Halo system in order to give you Wi-Fi stably up to 1 kilometer away from the base station, which is incredible. Again, if you would like to find out more about it, there is a Product of the Week video here. You can either head to the blog and just click on the link here and it will open it up on YouTube for you, or just find it directly through our YouTube channel. And as this is a Product of the Week, it will, of course, be part of a giveaway. Robin gives a wonderful description of the Morse Micro Gateway and all of the reasons why you might want to use it as part of your personal project or even part of your business. I do recommend going and having a look at his Product of the Week video and, yeah, entering the contest. It is time for funding website things, and we are back on Crowd Supply, which, if you're not familiar, it's similar to Kickstarter, but just for very awesome hardware projects. The team at Crowd Supply help everybody who comes to them with their ideas to get them into a state where they would be ready for launching, and then they are launched to the public where they can be funded in a similar vein to Kickstarter. Now, I've talked about many wonderful things on this site over the years, spent more money on it than I probably should have done, but today we're here to talk about the Open Book Touch. So, as you can see, this is an e-reader, a pocketable, open source, backlit e-reader with a touchscreen, hence the OpenBook Touch in the name. But before we even look at this, I just want to point out that this is from Oddly Specific Objects, Joey Castillo, someone we've talked about several times over the years on the show. Joey is behind the Open Book, which is the original iteration of this idea, a completely open source e-reader that you can build yourself, flashed with firmware that Joey has been working on for years to make a really stable and nice open source e-reader experience. This is the next iteration of that. However, we also talked about Joey when we were talking about the Sensor Watch, because this is another Oddly Specific Object, a complete rework of the hardware of classic Casio watches, putting a new PCB in there and adding a whole load of functionality. So this is coming from a place of a lot of experience and a project that has been working for a very, very long time. But the thing of itself is really quite nice as well. So we have an ESP32S3 behind the scenes doing all of the grunt work. And the front is a 480 by 800 pixel e-paper touch screen. It also has, I think it is 5 levels of backlight, if I remember correctly. Yes, 5 warm and 5 cool LEDs in the front light module with the native PWM capabilities, which allows for fine-grained dimming and color temperature control for reading in dark environments. So we really are getting into that territory where this is an open source e-reader that behaves a lot like the closed source e-readers we may already be used to, which I wanted to include in the show because if you're anything like me, this is a very exciting thing. So the full specs are listed a little bit further down this page, but just as it mentions here, there's 16 megabytes of flash memory for complex firmware and plenty of room for custom fonts, 8 megabytes of super fast SRAM for memory intensive operations like parsing EPUB files, and a crystal that allows you for accurate timestamping of anything you put in the micro SD card slot, which this device also has. So as it says, the full features and specifications are down here. One thing I'm sure many people will immediately start wondering about is things like battery life, and it's mentioned mentioned here as well. They expect it to achieve days to weeks of reading time and months of standby on a single charge thanks to its 1800 milliamp hour LiPo battery. That's all thanks to careful planning and to maximize the use of the S3's low power RISC-V coprocessor and a ton of lessons learned building the ultra low power sensor watch project that I previously have mentioned. Now, this is a pre-launch project on CrowdSupply. That means that there is no price for this yet. It has not been launched. It is not being funded yet. But if you would like to find out more, you can always enter your details here, where it gives you the possibility for an email address. Joey also has a Discord server for oddly specific objects. I believe if you just go to the main page of oddlyspecificobjects.com, this is his catch-all site for everything that he is making, and there is a link to the Discord server there as well if you would like to drop in and ask any questions about the book, give any suggestions about the firmware, all of that kind of stuff. I will be coming back to this when it does launch. I'm very excited about this project. I was excited about the original open book project, and I really love the ideas that Joey is putting into this. I really hope that this one comes through, and yes, I will let you know when it starts funding, but for now there will be a link to this in the description along with Joey's website. That has been our podcast for this week. Thank you so much for joining me. Thank you for your continued support. If you do have a podcast app that allows for ratings and things like that, please do give us a nice rating. And as I said at the start of the show, electromaker.io is our online store. I will be back soon with more new things to talk about, funding website things, new things to buy and develop on, and new projects as well. I look forward to that. But for now, as this is more than likely the last podcast of the year, I wish you a very good end of year, and I hope you enjoy celebrating whatever you celebrate, and I will be back to chat to you next year.